Hi everyone, welcome to our new unit of trigonometry. Today we're going to be talking about special triangles, which basically are two triangles that you will need to remember for a long time in math, and it just gives us angles where our trig ratios are exact values. So a reminder here first is that in trigonometry, a lot of the time we go back to that thing you learned in grade 10, SOHCAHTOA, which you can only use with right angle triangles. So to start off the first example, I have a right angle triangle here, and we're going to fill out some of the angles. So in this first special triangle, the angles that you need to remember is that there's a 90-degree angle. It all has to add to 180. So our bottom angle here is 60, and the top angle has to be 30 degrees to get it to 180. And it doesn't really matter if I put the 30 at the bottom or the 60 at the top. We can redraw it after. But what does matter here are the side lengths here. So in the first side length, we have 1 unit at the bottom and √3 on the side. It is important where those go in relation to the angles. So the way that I like to remember that is that 30 degrees is adjacent to square root of 3. So adjacent meaning right beside. So those have to go together. So if the 30 was on the bottom angle, then the √3 also goes on the bottom. And we could use Pythagorean theorem to figure out that hypotenuse length. But to save us some time, you can check it if you don't believe me, but it's going to be 2 units. And so with that now, we want to use SOHCAHTOA to find our primary trig ratios for each angle. So we'll start with 30 degrees, and we want to find sine of 30. Well, before we can even do that, you want to label your triangle from the perspective of 30 degrees. So the opposite to 30 is going to be across, so that's our O for opposite, A for adjacent, and H for hypotenuse, which is always across from the right angle. So following our SOHCAHTOA rules, sine is opposite over hypotenuse, so that's going to be 1/2. Super nice. Cos of 30 degrees is going to be adjacent over hypotenuse, so square root 3/2. And tan 30 is going to be opposite over adjacent, which is 1/√3. One little thing I want to show you here is that this is technically correct, but a lot of the times in your textbook and going forward, usually in math, you don't really like having the square root, the radical, in the denominator. I don't know why, it's really just a formality, but you might see it in your textbook. It's kind of like how, like in grade 9, you learn that you don't really want the negative sign in the denominator. You want to bring it up to the top or off to the side. So I'm going to show you how do we make it the exact same value, but make it look a little bit differently. So kind of like we did in when we were solving for rationals, we want to basically multiply this whole thing by 1. And I'm putting the 1 in quotations because it's like something that looks like that is 1, but we make it look a little bit different. So we would take this 1/√3 and multiply it by 1, which is just the same thing on the numerator and denominator. So multiply it by √3/√3. That's technically 1, right? This right here is just 1, but it's going to help us make our number look different. So we do our multiplication of fractions, which is numerator times numerator, denominator times denominator, and we end up with √3/√9. But we all know that this is actually a nice number, so we end up with √3/3. So back up in our ratios there, I'm going to say this is also equal to √3/3. Those are the exact same thing. They just look a little bit different. So that's part 1 of this. We also want to have sine of 60, cos 60, and tan 60. So from here, we have to take it from our perspective of 60 degrees, and we have to relabel. So now our opposite is over here, our adjacent is down here, and the hypotenuse stays the same. So sine opposite over hypotenuse, you get √3/2. For cos of 60 degrees, we get 1/2. and tan ends up being a lot nicer. We get root 3 over 1. We don't really need the over 1, so it's just root 3. We don't have to adjust anything. So that's special triangle number 1, and it's going to be useful, and we'll see some examples later. The second special triangle that we want to talk about is a little bit easier to remember because there's only one angle really. 45 degrees in the corner, which means if it all has to add to 180, our third angle also has to be 45 degrees. So it's the same. It is an isosceles triangle. Our side lengths are 1 and 1. And the hypotenuse, if you want to check it, go for it. But it's going to end up being square root of 2. So we want to find our sine 45 degrees, cos 45 degrees, and tan 45 degrees. So let's label our opposite, adjacent, and hypotenuse. Doesn't really matter. I'm starting from this angle here, but you could have picked the other 45. It won't matter. So opposite over hypotenuse is going to be 1 over root 2. You can try the trick that I showed you in the last example, but we're also going to say it's the same thing as root 2 over 2. Cos of 45 degrees, same thing with adjacent over hypotenuse. And tan 45 is opposite over adjacent, 1 over 1, which is just 1. So now we have 2 special triangles to remember and 3 sets of primary trig ratios that you can work out. Something that you might want to work out in your, add to your notes after you watch this video is maybe make yourself a little chart. I'm not saying to memorize this at all because I don't think you need to memorize a chart whatsoever. I think that makes it a lot more difficult. But you just might want it for organization. But maybe you want to fill out a chart like this with all of the angles and put that in there. I'm not going to fill it out for you. You can do this with what we just did, but it might be help you to organize it. But the most important thing to memorize is actually just the triangles, because once you have the triangles and their side lengths, you can figure out all of these ratios on your own. So we're going to do 2 examples together, and in both of these examples you'll see part A and part B. We'll do part A together, and part B I'll leave you to do on your own, and I will post a PDF of the written solutions so you can check and see how you do. So determine the exact value of each expression, and by exact value, what that means is no rounding. No rounding. Exactly what we were working with before, leaving it as a fraction is the best and the most exact. So with here, the first thing that you want to do with these questions, and I think just going forward, is at the top of every new page that you're working on with trig, put your special triangles, because the more you write them, the better that you're going to get at remembering them and using them as well. So here's my 2 right angles. I'll start with 60, 30, remembering that root 3 is beside the 30, 1 and 2, because hypotenuse is always the longest side, and the 45-degree triangle, 1, 1, and square root of 2. Perfect. So in question A, we want to do, starting off with cos of 30. So if we're looking at 30 degrees, from that perspective, we have opposite, adjacent, and hypotenuse. So cos being adjacent over hypotenuse ends up being root 3 over 2. And sine of 60 in the bottom. So if we're going from 60 degrees, we have a new opposite, adjacent, and hypotenuse. You don't have to write O, A, and H every single time, but I think it just might be helpful for you to see now, but eventually you'll be comfortable where you don't need to do that. So for 60 degrees, sine is opposite over hypotenuse. So we have root 3 over 2. And then we're going to multiply by tan of 45. So for tan of 45, again, we can label it opposite, adjacent, hypotenuse. Tan is opposite over adjacent, which is 1 over 1. So it's just 1. Notice how here on the left side there, we have the same thing in the numerator and denominator, which we know can simplify to just 1. And 1 over 1 is also just 1. So we end up with just 1. That one worked out really nicely. So with those special triangles still there, try out part B and check out your answer on the PDF. With example 2, we want to use the appropriate special triangle and determine the value of theta if theta is between 0 and 90 degrees. So nothing bigger now. That will be either tomorrow's lesson or the day after, where you talk about angles, what happens if they're bigger than 90 degrees. So you'll get there. So again, you can have your special triangles drawn there, and you probably already have them from the page before. So that's fine. So this one here, I'm going to save that for now actually, and we'll take a look over here at 2 cos theta equals square root of 3. Well, this doesn't really tell me anything yet because I need to have my primary trig ratio by itself, which means that I just want the cos theta alone, and right now it's attached to a 2. So what we're actually going to do is divide both sides by 2 to get rid of it and to have cos theta by itself. So cos theta is now root 3 over 2. So if we have our special triangles drawn out, then we will know exactly which one to use, right? We know it needs to have a root 3 over 2. And just by even drawing the first one out, I know that I have 1, root 3, and 2 right there. So the 45-degree triangle isn't really useful here because there's no root 3 in that one. And we also know that cos, based on SOHCAHTOA, is adjacent over hypotenuse. So which angle, 30 or 60 degrees, is going to give us an adjacent of 3 and a hypotenuse of 2? So looking at your triangle, which one is it? Which one has an adjacent side, or which angle is adjacent to root 3? And we know that the answer is 30 degrees because here's our adjacent and here's our hypotenuse. So therefore, we would say theta equals 30 degrees. In the past, you would have used your calculator and done your cos inverse button to get the angle by itself, but with special triangles, you don't need to do that. You can solve it just by using these triangles, no calculator even necessary. So try the same strategy with part B and check your answer after.